Okay, so we are gonna talk a little bit more about how to be able to build out some algorithm for using an array. And then the last exercise we're gonna use is going to be a vector, which is a dynamic array. Um, the reason why I wanted to implement this is because if for those of you who are applying for work, especially programming related jobs, you will likely get questions that require like search and sort algorithm because it's just a common thing in business. Um, and then it's also going to help you if you are taking discrete structure, which is like a course that entails programming um, and math. So we're going to touch a little bit on the mechanism of search and sort and then how to program it, along with learning how to use a different container, which is a vector in C++. So we're only going to do 4 exercises today, and then we're going to answer the last question for our lab. So you typically see that searching algorithm for programming is going to be using 2 of the most common methods, which is what you see with linear search and binary search. This is implemented in so many things that we use, not just to look for data, but, from when you're looking at like browser all the way to making the decisions and a lot of the things in computer science really rely on searching and sorting. So it starts with talking about there's 2 primary methods that's used, and you don't have to use these, but everybody in computer science know about linear search, and this is applied in other programming languages as well. So searching is a way that we can find a specific value in a container, such as if we're looking at for example, if I have a set of data, right, and I need to find a specific number or value. This is also when you are using an app and you're booking a seat at the stadium, you are actually using a search algorithm, or in a cinema, like at a theater, if you want to watch a show. It's also a way that we can, you know, gather information from the internet. So linear search is typically implemented for something that is smaller. If you have a very simple data set, it does not work well if you have a very large data set. And so that's the limitation with linear search. It would go through the list or the container that you have, and it's going to match up the target or your search key to every single element. So if you have 100 element, it's going to do that 100 times. So therefore, we don't want to have a very large array that we would work with linear. Linear works best if you have a very small data set, like I said, right? And it is simple to program for linear search. Typically, we're just going to start with an element, typically on the left, and then we're going to go and seek to see if there's a match. So for example, if you're looking at the container, I have 2, 4, 0, 1, and 9. And my target, my key, is 1. So I'm looking for the number 1. And so for every single element, we can loop through the array, and we want to match the 1 to the elements that's in the array. So the first element, it's not going to be a match because 1 is not 2, right? And it's going to continue to go to the second element, the third element, and so on until it finds a match. So if your container or your array is very large, and if your target is at the end of the array, it's going to take the program a long time to find that result. Okay, so that means that your linear search, as it looks through every single element for a match, it would not be ideal in a large data set. And so when you learn data structure, if you're taking 17C, they'll talk about time complexity. So the time for this particular search is really depending on the end value or the size of your array, or the number of elements in your array. So in this case, we have only 5, so it could be fairly quick. But if you have 5,000 or 5 million, it's probably not best to implement linear search, okay? So it gives you a little bit of image, and I borrowed this from ProgramMIS because I thought it's probably easy to see what it's really trying to match. So it's sequentially go down the line, and it's gonna find a matching with the value at a specific position. And that's how you're gonna be able to get the result. So when you work with a linear search, the algorithm is going to be that you are going to pass the array and the key, which is your target, right? In this example that you see in the image, my key is 1. So that key needs to be implemented so that way we can loop through and we can set up the condition to match up the value for every single element that we have in the array. So you typically see that the algorithm will be this way. And in the example 1, it shows you on how you can implement linear search to find a student score. And just like all the other programs, your header file is the same, or your library that you implement is IOStream. And then I want to have a return function. Typically, you would have a function, whether you want it to return or not return, but you want to implement a function. And inside that function parameter, I'm going to pass the array, which is called ARR. And you can tell that it is an array because it has the square or the bracket. I'm also going to pass the size of my array, right? We talked about that on Tuesday. And then I'm going to pass the target, which is the key that we're going to find or we're going to search for, okay? Now, because there are multiple values in the array, we are going to implement a for loop. So it's going to, and for each loop, it's going to check each element in the array to make sure, right, that it can find a match or not, right? So it's going to check every single element through a for loop. And nested in the for loop, we would have the key value, which is your target. Okay, so it's going to try to see if the element is equal to the target, it's going to return, right, that particular element. That means that it found it. If not, right, it's going to return -1. That means that it's not found. And typically for C++, right, -1 just indicated that that's not achievable. That's not found. So now, after you define your function, and this one we're not prototyping, right? So we define it above the main. We are going to set up our main. So our main consists of the array. So that's typically the approach. You would have a function for your search, and the mechanism for that algorithm is going to go into the definition of that function, like a for loop, and the condition to look for that search key. Then in your main, you're going to set up your array, right, which consists of these values. And we know that the size of the array, it has 5 elements, so we would state the size. And a variable for your target, which is going to be your search key. So once that we have that in the main, we would prompt the user to enter the search key or the target. So in this case, we're going to ask the user to enter the score that they're going to look for. And it's going to record that input into the target. So that way it's going to use that to match for every single element that it's going to loop through. Okay. Now we are going to call on the function, right? It's because we need to find that score and it has to loop through. And we're going to pass, remember what we talked about when you do a function call, you don't put the type, right? We're going to pass the array, the size, and your key. So, and for the function call, we're going to store that into a variable because we're going to use that in our output. So if the result is not -1, that means that it found the score. We're going to take the result and we're going to do a +1. So it found it at the position at a certain position of the element. That's what we're going to show. And then else, it's going to show that the score is not found. So in this example, it simply implements a linear search where it seeks through the array. Every single element is going to be put into a loop, and it's going to try to match your search key or your search score to each element. If it found it, it's going to show the position of that particular element. If not, it's going to show not found. Okay? So typically, linear search is easy to do. You simply just create a function with a loop and then state the condition for the match nested inside that for loop. So in my discrete structure class, CIS-7, I go over the extension of this algorithm, but there are multiple ways that you can program it. It doesn't have to be this specific way, but this is a common way that you see. So when you work as a programmer, a lot of the times you can implement this for realistic use, right? We see this in everyday's life functionality, from the time that you are using the internet all the way to making the decisions for your devices, or even in the IT area for my students that are in cybersecurity. So for exercise 1, you're going to use that same example. And what you're going to do is you are going to implement a function for your linear search in your C++ program. And we're going to use that to search through the array. And our array would consist of the username. And I give you the username, John, Jane, student, and admin. Okay? So we're going to implement string. So don't forget to include string at the top. And we're going to prompt the user to enter the username that they're going to search for. So let's say that you have a database of all your users. Let's say you work in HR and you're setting up accounts for the people you hire, right? You want to search through and the database to be able to look up a specific username. As you know, the system doesn't allow you to have 2 of the same username, right? Each user have to have specific unique name, right? So this is what you see in your student email. If you have a common name, typically they add a number to your name so that way you don't have a conflict in the username with other people, other accounts, okay? So we're going to display the search result so that way when we test it, it's gonna show the appropriate output. Okay. All right. So let me go to my project. I meant to, okay. Okay, I did fix it. I thought I didn't fix it. Okay. All right. So as you've seen in the scenario that we were given, we are looking through text, names. So we have to include string at the top along with IOStream. Okay. This allows us to be able to implement our string as username. So at the top, you would say include IOStream, and then the second line would be include string. And after that, we would have using namespace std, just like what we've been doing along all these weeks. Now, just like the program that you see in the example, I'm going to have a returning function called linear search. And in its parameter, for the definition of the function, I want to pass the array, which is users. It's named users. And the array size, right? When you work with array, those two components goes into the parameter of your function. And then I want to pass the third parameter, which is going to be my target, which is the search key, right? The user that I'm going to look for. So in a linear search, you need those three parameters to be able to implement the mechanism with the loop and the condition. So just like the example program, I simply would loop through the array, which is called users. And I would start with the first element, which is element 0, position 0 for the first element, and I would go up to the size of my array. And in this case, we only have 4 users, so it's going to go up to 4. 0 to 3 is going to give us 4 users, right? And we are going to increase after each loop. So it's going to go loop 1, loop 2, loop 3, and so on. But I'm sorry, loop 0 all the way to loop 3. And we want to implement a condition because linear search simply takes that username and match it with whatever that you have in the array for each element. If there's a match, right, we are going to say that it's found. If there isn't a match, then we are going to return -1. So if it found it, it's going to return the location of the element in the array. It's going to return the index. So when you test this, it's going to show you the location of that name in the array, okay? Now you can do something more to this where you can do a cout and say found, you know, so username, blah, 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 right? You can. But I just want to simplify the program to kind of match the example that you see. So we're going to return the index of the username if it found it. If not, right, else, we don't have to do an else here. We can do an else. So if it doesn't find it, it's going to return -1. Any question regarding the algorithm for linear? So it is very sequential, right? It's going to check each element in each loop based on the if condition that we state here, which is to match the target, which is the input by the username, to our user array, which is a container that has all the users. And then following that, we would have a main. And in our main, this is where you set up your container, your array. You would have an array that contains string because we now put in the username. So if you're using name or text, right, you want to put string if it's multiple characters. So we want to type that as a string. And we want to have an array called usernames. And you can call your array whatever you like. And then given in the program, I have 4 users. I have John, Jane, student, and admin. So I want to put those into double quotation marks. So C++ require double quotation marks where other languages might allow you to use single or double. So double quotation marks. And if I count up all the names, all the username, I have 4, right? Remember how we talk about how it can infer, but in this case, we just want to state the size of our array, which is static. It's permanent. It's 4. There are 4 usernames, so our size is going to be 4. Can you do a constant size equal 4? You can, because it is a constant. You can also just have it int as a type, int. And we also have another variable called target. That's going to be our search key, right? Our search user account. And line 29, following that, I have a cout. I simply put that for aesthetic purposes. So I put username search system. That's my app intention. And then I want to prompt the user to enter a username. So I do a cout, enter username to search. You want to give it a space after the colon so that way it doesn't stick together so close, so it looks nicer. And then once the user entered the username, it's going to store that in the target, which is what we define on line 27 here. And it's going to take that target, right? And it's going to match it to the index. That's what your if condition is made to do in your function, right? And so with that, we then now call the function. So we have a variable called index, and it's going to store the result of the function call. So we would call linear search function on line 36. And because it's a function call, we simply pass the array name, the size, and the target without type. Okay? So the logic in linear search is really simple, right? Check every single element for a match. If there is a match, display the result. If there isn't a match, display -1 or not found. Okay. So this tends to come up with employers a lot for interview questions if you're applying for programming, right? Sometimes they want you to do an efficient search and sort algorithm for a set of data that they give you. And you have a limited amount of time to do it. So this technique is a very common technique that you see for programming in general in any languages, right? Difference between C++ and Python and Java is just the syntax. Any question regarding linear search? Okay, we're not finished just yet, right? We still have the last part, which is after it does a function call, we want to implement a condition. If the index is not -1, why do we use -1? Because the indices of your element starts at 0, so anything below that would be not found, or like it won't have a match. So we would say if index is not -1, then we would display, let me kind of go down a little bit. Sorry. It's kind of it's a tiny bit smaller. I just want to make sure you see the entire line. If index is not -1, then we would display the username, right? And bring down the target that which is what the user input is found at position, and it will be index +1. So it simply display the username is located in this element position. Else, it's going to display username, and then the target is not found in the system. So, in when I do IT auditing, I typically require the people that work with the account and access servers to do an inventory of their list of users. So, and then if you're looking at a certain technician, they typically having to identify like which user account and how to create the user account that is not conflicting with other user accounts. So you see a use of this in a technical perspective, like in an IT area, but you can use this to be able to do a search for inventory for groceries, for, like let's say that you sell fruits and you wanted to see if there's a fruit that you carry. You can use like the string to identify your fruits like grapes, apples, bananas, and so on. Or name of students in a class, etc. So it can be applied in so many ways, right? But like I said, linear search is not the most efficient search algorithm. It is easy to understand, but it is ideal for very tiny, small data set. Now, there is another way that we can implement recursion that will probably be in another class. I'll talk a little bit about recursive function maybe later on, but you can recursively look through, however, we will save that for the binary search algorithm in the next part. Any question regarding, so I stuck kind of close to the example that you see. So if you want to match that up to the example and modify it a little bit, you can. It doesn't, it doesn't have to be completely different. The main thing is that we're using string. So you want to say include string, and then our array contains the names of the user account. And then we have a little bit more display in the results, so it's more user-friendly. Okay, so if you want to check your top, just your function definition. Okay, so test the program. You can type in your name to see if it's giving you a return that is appropriate, right? Like, is it saying that is your account found or not found, right? And then you can test it with an account that's in the array, like student, admin, Jane, or John, then to see if there's a match. But you can also see something like this used in automation, right? You can have system identify another system, possibly by name or by specific network addresses, and be able to activate a certain service. We use a lot of that kind of technique in Python, especially for IT automations or server automation. So you see some of that as well. Searching mechanism is used in everything mostly that functions in our world. A lot of your application has that. Any questions regarding linear search? So I'm working on updating your grade. Sorry, I was trying to do some of it, before my meeting today with my department. And then I will work on it tonight when I have office hours after this. So, okay. Are we okay with linear search? Can I progress? I don't want to make it too fast for you. So now I heard that the universities are doing coding camps, right? Especially Davis, etc. So if you transfer as a computer science, they not only having you, so this is how they're gonna determine where they place you in the classes, whether you would continue in some of the lower division classes or having to take some prerequisite. So even if you get some transfer credit, right, you have to go through a few weeks of coding camps. And so they assess you based on how well you do. And you're going to see a lot of it has to do with, some of the concept that you get from some of these classes are going to come up again. So they want to see how fast you can write an algorithm like this because it's a basic concept in many C++ classes. So I would suggest that you practice this if you want to pursue computer science or software engineering because it will come up again and again. Okay. All right. So once you complete your program and test it, provide the screenshot. Don't forget to do that and make sure you save your document so that way you can submit it at the end or at the end of the week. Another search algorithm that you typically see, and this is very commonly applied, more than linear search. This is one of the better algorithm, is called a binary search. Why is it named a binary search? What it does is it takes your array or your container and it cuts it in half. And then from there, it cuts the half into half, so become a quarter. And it's going to chunk it into half until it gets to the smallest halves unit. Okay, so let's say that if you have 100 elements, first it's going to divide that into two halves, which is 50 and 50. Then it's going to take each of the half, which is 50, and it's going to cut it in half again, which is 25, 25, 25, and 25. And it's going to reduce that until it gets to the smallest halves. So that way it can quickly identify, and this is one of the best algorithms to implement. The binary, the name of it is just mean two. So you would take your container and divide it by twos until you get to the smallest unit so it can seek a match in your key. Okay, so if you understand that concept where it keeps dividing it into half, you're going to see that implemented into the algorithm itself. So this is ideal if you have it pre-sorted. It works, so you have to have it pre-sorted. Okay, so that means that you probably have to implement a sorting algorithm before you implement a binary search algorithm, or if you have data that's already pre-sorted. And it works very, very fast. Okay, exponentially faster than your linear search mechanism. Okay, so repeatedly divided in half, and typically you're going to see a do while in this particular case, or a while loop being implemented. So, and it's going to use a pointer. So a pointer works this way. It takes a variable which contains an address and it points to another location, which is another address. Okay, so for example, you live in a house that is at the address 12345. And in order to find your house, I have to go to an office, right, which is at a different address, 45678. Okay, so the office is the pointer to your house. So in order to find you, I have to go to an office, and that office has a different address than your house address. So that means that it uses two addresses to locate the data. Okay, so now because it's sorted, we're going to have the low half, which is the beginning half, and that's on the left, and the right half, which is the high value, that's on the right, right? So if you have a pre-sorted array, it cuts it in half, and it knows that the first half, on the left, is the lower value, and the right side, the second half, is containing the high value. So what we have to do is we have to create a midpoint, and that midpoint is going to allow us to cut it in half. That midpoint, how do we find it? We would take the low half, add it with the high halves, and divide it by 2. Okay? And then we are going to start with the midpoint. So if x is equal to the midpoint, it's going to simply return. That is right in the middle of your array. And sometimes that's the case, right? Otherwise, it's going to check, is it larger than the mid? If it is, it's going to go to the right side. If it's not, then it's going to be to the left. Okay? So that's how it's able to determine where your value would be, by keep dividing everything in halves until it checks either the left side or the right side by the match. So the recursive method is what you see a lot of the developer, the programmer in the industry is using. It is a little bit more lengthy than the iterative method, which is what you see. There's two approaches in binary search. Okay, so for the recursion, you simply implement a function, you pass your array and your search key, the size, along with the low and the high variable that represents the left and the right side of your array. And then you would implement the condition, right? If low is greater than high, it's going to return false, because that's never the case if it's sorted. So in some case, if you don't have a pre-sorted array, it's going to return right here. It stops the program, okay? Else, we're going to continue. We're going to find the midpoint of our array, and we are going to check to see if the value is the midpoint. If it is, we're going to return that. Otherwise, we're going to determine whether it's going to be on the right side by checking, is it greater than the midpoint? If it is, then we're going to return, and this is why it's recursive, is it's a function calling a function. Okay, so we do a function call within the function. Okay, and it's going to do a function call, and then it's going to do a +1, because now it's going to then return the mid +1. We're going to pass all of these into the parameter. Otherwise, we're going to check the left side. Okay, so simply it's divide and conquer, right? It's going to check the right side. If it's not, then check the left side. Okay, so I give you a little bit of visual. This is the array 3 to 9, right? We're going to take that and we're going to cut it in half, so the 6 becomes the midpoint. And then it's going to see if the value that you're seeking is a 6. If it is, it's going to return. If not, right, we're going to check. So again, on the left, you're going to have a high and a low, right? The left of the left is going to be low, and the right of the left cut is going to be high. So 5 becomes high and 3 becomes low on the left side, whereas 7 becomes low and 9 becomes high on the right side. Okay. So the logic in that, so once we do that, we're going to cut it in half again by creating a midpoint, which is 4 on the left. And if it's found there, then it's going to return 4. Okay. And this is why it's quicker, is because it's able to keep dividing and finding the midpoint and then conquering the left and the right by low and high. So exponentially, you actually have O is to the n squared compared to a linear search. Okay, it's a lot faster. Okay, so the example I give you is there. You can see that it's very similar to what you see in the actual algorithm that you saw earlier. And this is the array that we're using, right? So we're going to use this example and we're going to create the next exercise. Any question regarding recursive? I know this might be a little leap higher, but I want you to take a look at it so that way when you come across it again, you would know, right? When you take the next classes, it's going to be easier for you instead of learning it there. Sorry, that's my meeting minutes. Okay, let's go to the second exercise. We're going to use example 2. We're going to implement binary search function using a recursive method to search for product pricing, right? And you're given the prices here, so these needs to go into your array. And you need to prompt the user to search for a specific price. So we're going to do a cout and C in there. And then we're going to have a function that's going to do a binary search, similar to what you see in the example. And we're going to search through the given prices, and we're going to display the appropriate result. So let me show you. Let's close the ad. Maybe increase the font a tiny bit. And let me pull this down. Okay. So I have the same thing at the top. We talked about that every single time. So I have a function similar to your example called binary search. And its parameter consists of my array, which is named ARR. You can call it prices or whatever you want. Just make sure it matches throughout. I have the size of my array as the second part of the parameter and my target. On the left, I want to have a variable called left, and I initialize that at 0. And then on the right, I'm going to have the size subtract 1. Okay. And these are going to be the variable that we're going to implement into our loop. Like I mentioned, you typically see a do while or a while loop with binary. So I would start with the while loop. So I wanted to check for the condition. If left is greater or equal to right, I am going to take that and divide it into half. So it's going to create a midpoint by doing left plus right divided by 2. And if the midpoint is the target, we're going to return the midpoint. That's the value in the middle. Else if we would take that and check it to see if it's less than the target. If it is, then it's going to be midpoint plus 1. Otherwise, we're going to go to the right by doing mid minus 1. And if it cannot find the match from your search key, then it's going to return -1. In my main, I would then define my array. It's going to contain prices, so I have double prices, and I would list the prices that were given to me in the problem. So $5.99, $9.99, all the way to $25.99. I know that there are 6 prices by counting them up, so my size is 6. And I have a double target. It's type double because we're working with prices, right? You have some decimal points for cents. See you. You too. Any questions so far? Do you guys understand why we're doing a +1 and a -1 here? This just indicates the element position in human aspect. We don't say the first element is 0, right? We actually say the first element is 1, like the position is 1. So that means on the left, it needs to count 0 plus 1. And then on the right side, we have to subtract 1. So it would be the opposite of what you have on the left, okay? So that's why you have these value added and subtract there. And then after we define our variables in our array, we would have some C in and C out. So I would have C out. This is my product price lookup program. And then I would prompt the user to enter the price to search. And I would record that input into the target variable. And then in the next line here for 37, I have the function call. So, and variable index is going to store the result of my function call. So binary search function is called here. And you want to bring down the parameter, which is your array, its size, and the target value. So it simply applies, right, the values that were processed in that function. I was looking for it the other day when I had my allergy, so I found something that's true. You guys need tissue? I have a box of tissue up here. Okay. Then we have similar to what you've seen in your example program, right? I would check for the next condition would be for the index. If index is not -1, like we said, right? Index starts at 0 for array always. So if it's not -1, then we would be able to find it at the position. So we would do an index +1. Don't forget the end line in the semicolon there. Else, we would display products not found in an inventory and we would return to 0. So very close to what you've seen in the example program. Um, So let's say that you have a store and you want the store to, you want to apply certain discount to a certain price, right? You might have items that you're selling at high price, but you want to encourage the customer to buy your item. So you can seek through your inventory and say, let's say $25.99, anything above that or anything with $25.99, we're going to give the customer $1 off, for example, or a certain percentage off. So that way it would encourage them to buy the product with higher price, right? And it can go across like, multiple products or individual type of product. So there are all kinds of application that you can use binary search for. So does it really matter whether you're using a specific technique for binary search? Ultimately, however you approach the problem in dividing the container in halves and halves again, it's just different ways to do that, right? Now recursion occurs when you have a function calling a function, but you can implement the iterative approach where you just have a function definition and then call it inside the main. So um, you can have different approaches to solve the problem. Ultimately, you just have to understand how to be able to build out binary search, right? By breaking the container into halves and keep doing it and checking the left and the right side. So the left, it's going to become low, and it's the left side, the right side of the left is going to be high. So as long as you understand the logic in that, it's a lot easier to kind of grasp on how you would implement the code for it. So I spent a week in discrete structure to talk about like the actual mechanism for this, and then they do um they look at the math on, when we do a search mechanism, what is the proficiency or the efficiency level for that, right? And then how to write that in C++ as well. And that can be expanded into the statistic part of what you see for the analysis, right? Um, like the possibility or the likely of having a certain result out of the search. Any question? Okay, so test the program. You can test it with one of the known prices in the array or a different price that's not in the array. See if you can get the appropriate result. and then screenshot that. 2 down, 2 more to go, right? Okay, so um, similarly, you would see that there are different techniques into sorting. You see this with your applications, like if you're using Excel, um, you know, even in your file management for Windows, like you know how you can click the name and it sorts it by name. You can click date modify and it sorts your file that you recently modify or edited, or the oldest file that you have edited, etc. So you use this all the time, right? But what we're gonna do is I'm only gonna focus on bubble sort. Technically the application for bubble sort is not that efficient compared to insertion or selection sort. But if I spend, so this by itself is like a whole chapter. So I'm gonna just give you the bubble sort because it's a common sort mechanism that people discuss for C++ or programming. And so when I teach assembly at low level, they have to know how to do this and to at the low level programming. So I wanted to touch on bubble sort so that way you kind of know, and it's easy to understand. So we know that sorting is a way that we can arrange the elements in order. Sometimes it's low to high and high to low. We can do ascending, that's going to go from low through high, like A to Z or 1 through 10, versus descending, that's going to go from high to low, like Z to A or 10 to 1. There are different mechanism or different algorithm that you can implement for sort. We're going to touch on bubble sort today, but you would see that there would be selection sort and insertion sort. Selection sort and insertion sort is like when you're playing cards and you simply take the cards that you are dealt and stuck it in the order that you are dealt the cards with. Not the order of the card number. So and then selection sort, you can select, it's very similar to what you've seen with binary. But anyway, for the bubble sort, we are going to compare the elements to the next element. It's kind of like you're standing in line, right? You're waiting to enter, like maybe the airplane, and you check what the one standing before you or after you on their seats, right? Where are you sitting? And they would tell you, I'm sitting at A6. And you said, oh, okay, then I must be sitting at A5. So bubble sort is a way that we would compare the elements to the next element. And if it is higher, right? If the current element is higher, it's going to switch place. So we're simply bubble out. We just swap the spot until we can get the right order. So, for example, if you're looking at the image, right? Let's say that I have, this is my array, -2, 45, 0, 11, and -9. So it's going to take the -2 and it's going to compare that to the 45. If it is lower, it's going to keep it in the same position. If it is higher, then it's going to swap the place. But I'm going to tell you, in the computer, there's no such thing as swapping the two. You have to move the -2 to another location, and then you are going to move. It's a triangular move, right? So it's like you cannot switch the place. There's no magic position for you to swap the place. So in order to move the -2, I have to put it into a temporary location, which is my another variable, and then move the 45 into that element position, and then move the -2 from the temporary location to the 45 position. You understand? So it's a triangular move, okay? There's no magic thin space where you can just take that and switch it over. So in order to swap, you have to move it into the temporary and from the temporary to the position of the previous element. Okay. And then it's going to keep doing that for every element that's adjacent to. So we're going to bubble out from the left to right until it gets the right order. Okay. That's a bubble sort. So just compare to the next element. Okay. So in this example, I show you how you can swap the values for scores using bubble sort. And in this example, we're using a void function, which is a non-returning function. And so we're going to pass the array as its parameter and the size. And we're using the type bool here. That's going to give us true or false because we need to check to see is it smaller or larger. If it is smaller, we're going to keep it there. If it's larger, we're going to swap, right? So we're going to check true or false there. And it's going to loop through our array and it's going to check, right? Should we swap or shouldn't we swap? But within that, we're going to nest another array to be able to implement the condition. If the value is greater than the next value, that's going to be the position +1, then it's going to move that into a temporary location, like I said, so that way we can do the swap, okay? Because you can't just take it out of its position. You have to put it into a variable so that way it will remember your value. Otherwise, you cannot swap it, okay? And then from there, we are going to move it into the adjacent position. And then we're going to take whatever that was in the adjacent position, put it in temporary. And then that's how we move that triangularly. So if it's not swap, then it's going to break from the program because it stays in its own position to start or from the start. And then in the main, make sure that you define your array, the size of your array. And again, we are going to loop through to display the original score from the array, which are these values. And we're going to call the bubble sort function that we previously defined. And all we have to do is specify the array and the size of the array. And then we want to display the score in ascending order after it's sorted. So you have to do a for loop for before it gets sorted and another for loop for after it's sorted. So we are going to loop through and we are going to display each of the score after it's sorted. And that completes the program. Okay. So for exercise 3, Easy Sales Manager wants to sort the prices for the items from lowest to highest and display the price. And the prices are given here and they are not in a sorted order. You're going to write a program. We're going to implement a bubble sort algorithm to display the lowest to the highest price, right? This one should be simple, kind of similar to what you've seen here. We're going to go ascending order. Okay. So just like the program that you see for example 3, I have the typical IO stream library at the top along with using namespace std. I have a void function. This is going to allow me to do a bubble sort. In its parameter, we are going to do the price array and then the size. Yes. Are you leaving now? Okay. I know your name. Thank you. And then we are going to use a bool type for the swap, right? To check to see if it's swapped or not. for the last condition that we state. Then to do the swap, we are going to need to loop through, right? For the bubble part, we're gonna have to check to see if it is less than in the value for compared to the adjacent, which is the one next to it to the right. So we're gonna loop through our array, start with element 0. If we don't swap, if swap is false, we're gonna have an inner loop. And in this inner loop, we would start with the element 0. We're going to go size is going to be index minus 1. That's going to be 1 less. And we're going to increment. If the value of the price is greater than the one to its right, we're going to move it to the temporary location so that way we can begin the swap. We're going to move it to the temp variable. And then we're going to take the price on the right side, and we're going to move it to the index location for the first price. Yes. Salazar, right? Bye. Then we are going to take the one on the right side and move it to temp. And that would complete the swap. So this inner for loop allows you to do a triangular move for the swap. First, you are going to take if the price of your current index is greater than the one to its right, you're going to put it into the temp location, right? Take the one to the right side of that price and move it to the location of the first price, and then take the one from the right and move it to temp. So that's how you're able to switch places for these prices. And then we would have the next condition. We're going to check for if it's swap, we're going to break from the program, stop early. That's already sorted. Then in the main, we're going to have our array, which is given in the problem. You can copy and paste it in. And then if you count up the prices, we have 5. And then following that, I just have a display of what my program is about. So product price sorter, you can call it, however you like. And we would then work on the loop to display the original price so we can show that it's sorted. So we would loop through the original array, bless you. So we have 4. We would start with the index 0, go up to the end of the array by its size, and then we would increment after each loop. We would display the price by the index. And then after that, we would then call the bubble sort function. So for the new C++ version, you can do it all in one line like this. Same thing with Python. Versus if because C++ doesn't require indentation, so you're able to keep it on one line and not having to put it into the body. But you can have it like the traditional way. And then we would then display the sorted value. So after we do the function call to sort, right? We then now can display the sorted. So when you do the function call, what happens is it's going to update all the value in your array as a sorted value. And then after that, you would then loop through the same array because it's already updated at the function call here. It's going to replace all the prices by order from low to high. Then when you loop the second time, it's going to show all the appropriate prices because the order has been done after the function call here. Okay? So when you loop it right here, it's going to read through the array because the array now contains the updated sorted value. And we're going to output and return 0, and that will be the end of our program. So it's not that difficult. It just do a swap. I think the swap mechanism, if you understand how it moves the element to the temp location and from that temp location to either to the right, then you would understand how that works. Realistically, bubble sort is not a truly efficient algorithm to implement, but it's easy to understand. You often see insertion or selection sort for sorting in programming. So very close to what you see with the example program. We have a different array, right? Any question? So test it to see if you have the sorted values. Okay, I would encourage you to repractice, right? You can think of a scenario and you can write your own function from scratch without looking at the code. Like I said, if you are pursuing programming jobs or go to transfer to the university, sometimes they give you assessment for coding or, in order to interview or place in a class, you just want to make sure that you can do it correctly. And you will have more practice in other classes as well, but it's good to practice now. Okay, so we have 3 completed. We will work on the 4th one and then I will do attendance and we'll call it a day. So we've talked about linear search. We've talked about binary search. This is a bubble sort program. And then on the last one, we will talk about vector, which is a dynamic array. So if you continue to use the textbook that Mr. McQueen has referenced in this class, if you read chapter 7, it really encompasses the things that I implemented in your Tuesday and Thursday session. I try to stick with the chapter objectives so that way you would still get the same content. So if you want more practice, you can go back to the book and look at the exercises and then also read the concept from the textbook. I wanted to encapsulate all of these onto documents so that way you don't have to go back and forth to the chapter. So you can look at the example and be able to program similar to what you see in the example, and that helps you. But your textbook, I know he posted that in Canvas, so you can use it. And as a good reference, that book is not bad. When I taught C++ before, I used the same textbook, but I also customized my exercises similar to what you see now. Okay. Any question regarding bubble sort?
I think we're gonna get the first.
Okay, I'll roll up now. There you go. Now, if you prototype this function, right, you just need to start with the prototype, which is the function name and its parameter, semicolon, and then just make sure that you define it at the bottom after the main. So just the placement is a little different. C++ has its unique, I know Java's too, but that's just the practice for C++. But if you learn Python, you would see that you don't have, there's, main is not required to say int main, right? But it's there at the bottom, so you can just do a function call at the bottom and it automatically does it with the interpreter. It's a lot less in like syntax and requirements in what you typed into your code. So, and it's more intuitive. So, that's why you tend to see that people prefer Python over other languages. But, you know, some people, they like C++. And you see jobs require your knowledge in C++ too, so. So if you aspire to be a Windows application programmer, like making app for Microsoft Windows, you will need to learn C#, which is similar, but not exactly the same. Syntax are different and there are specific things for C#. And then if you aspire to be an iOS developer, you need to learn Objective-C, which is, you know, a lot of these languages are C-based. You're going to see similarities and common things. But just like learning Spanish compared to Latin to, you know, a similar language, you would see that there's some differences in how it's written and how they speak it, right? So just like that, you are going to get different syntax and different practices in different languages. But understanding C++ is going to help you in other languages for sure. And if you look at the example, this exercise is very close to what you see with the example 3. Any question regarding bubble sort? We should make time. Should be all right. I know some of you have to leave around 4, but okay. Are we okay with exercise 3? Yeah. At the top? Oh, you need help? Yeah, I was like, did I miss that or, okay, yeah, your J has to be J. The inner for loop has to be J. I get it. I do that sometimes too. Okay, are we good? Any other questions or help? Yeah. Is it okay now? Go back to your code. Move J. Oh, it's I are used it. Low. Low is less than high. Low arrow. Shit.
It's number 39. Or it's like
Yeah, make sure your low is the way you type it is matching. So, oh, yeah, oh, that,
yeah.
you don't have to put that. You can put two, like T,
Okay.
T-O, but you can do also this way. Because it's a comment, so just. It's a comment, so you don't, or the text, I mean, the display text, it doesn't really matter. Okay, any question? Did that fix it? Your J and your I's? Or is it, okay. Yeah, because that is an error where it's nested too deep and it's confused, like which address does it read the variable from? So that's why it's telling you it's an address violation error. Okay. So the takeaway, you guys see that the bubble sort, we need to do a swap, right? And a temporary variable is used for the movement of your data. Okay, so while you're working on that, I'm going to talk about 4, which is vector. So vector is a dynamic array. This is when you're uncertain on, how big is your data set. If you have growing and shrinking set of data, you want to use vector. When we're uncertain about the number of elements, when your values can change inside your container, you can have, less values in your array or more values in your array, you want to implement vector. Keep in mind that you are going to include vector at the top, and it is an STL, so it's a standard library for C++. With this, you will be able to implement built-in functions that already been created for that container. So array compared to a vector, it is a fixed size. So whatever number of elements you have, you define that in when you initialize your array. and your allocation for your storage is pretty fixed. It cuts up the number that you need. So let's say that your array is 5 elements, right? It cuts up the 5 slots for your elements. Each one would have appropriate addresses. Whereas in a vector, it does a larger allocation, and it can also adjust the size and the addresses as you need. So it is more flexible. It is not as limited compared to array. Now, when you look at some of the functions, you can do a pushback. It adds the element to the end of your group of values. Whereas you do a pop back, it's going to remove the element at the end. So when you want to add, you push in, okay? When you want to remove, you do a pop back, which is you pop out, okay? So it's just going to take the last value at the end and it's going to remove it. And it's going to then take that address and make it available, it's just going to not put any value there. So it's going to shrink the container down. It's kind of like, how you have well, let me see if I can have a certain analogy for you. You have a container. If you need to contain less item, you can shrink its size down to one less, right? And so when you do that, you're going to do a pop back and it's going to automatically shrink it down, okay? You can also clear elements where you can remove everything, okay? So if I want to flush out all the values, I would then clear at the end and it's going to give those addresses back to the system. You can also do front, where it's going to access the front, back, and then also index. So these are some of the common functions, but there are more. So you can reference, I put a link here, you can go and look, and they have some information on different functions you can use. Okay, we can use an add function where it's actually looking at it access the element, and this one does a bound check. Whereas if you do front or back, it's only either the first or the end element, and it doesn't do a bound check. Okay, so exercise 4, you can refer to example 4. This one we use a vector, STL. We create a vector by saying it is a vector. You put a vector and then the type, you're going to put it inside after a vector, and you're going to put it inside your arrows like this, okay? And then you give it a name. So that's how it can tell that it is a vector, by saying vector and then the type and then the name. And so this program allows you to record sales, and we don't know how many, or we are uncertain about the sizes. So that's when you use your vector. Okay. And then we implemented a while loop. While it is true, so it's always going to keep running. It shows the sales record. It requires the user to input that sales record into the system. And if the input is -1, it's going to break from the program. After each input, it's going to do a pushback. It's going to add it to the end of the list, okay? So it's going to keep adding the sales as we have input. So you do a pushback there. So you notice that this is a function that is built in. So you simply take the vector name and you do a dot and then you do the function. This is what we call a method where it acts as a property of that container. So it's going to add the value to this container called sales from the input. Okay. And it's going to do a running sum for us. So here we implemented a for loop, and that's going to allow us to calculate the total and the average sales. So for 4, you're going to refer to the example. You are going to simulate a online shopping cart. Okay. We don't know how many items the user are gonna add to the shopping cart and the prices. Okay, so we are going to implement where we would ask the customer to input the prices for their item, and we're gonna keep pushing it to the vector. Okay, we're gonna keep adding that to the cart. Okay, I'll show you how this is done. It's actually a really short program. It's not that long. Okay, so at the top, you would have include IO stream to be able to have input and output. And then we need to include vector because we are building a vector container. So that's needed. You are going to have using namespace std, just like all the other programs, so you don't have to put std in front of cin and cout. I didn't do a separate function for this. It would just be everything in main because I got tired. So vector is going to be our container, and this is going to be a type double. So you need to put double inside the arrows like this. And you are going to name it cart because it's an online shopping cart. We have a variable called price because that's what the user going to input for us, and we're going to tally up the price. And then we also have a variable called choice, and it's a char for character, yes or no. You can name it however you want to name your program here. I put a shopping cart system. You can say online shopping cart, whatever you like there. I have a do while loop. It's going to prompt the user to enter the price. It's going to keep doing that. And as the user input, it's going to store the input into the price variable. Each price that is input, we're going to push it back. We do a pushback to the cart, which is our vector. We're going to keep adding it. And we're going to prompt the user, do you want to add another item? See you later.
You're gonna post this tonight?
Yeah, I will. So if they want another item, they're going to type yes. So it could be lowercase or the uppercase. We just want to make sure. So this is for input validation. While choice is a lowercase y or an uppercase y. We are going to initialize the total to do a running sum. Then we're going to do a for loop for double P, which is going to be we're going to keep adding the price from the cart. We're going to do a running sum for the prices. It's going to tally up everything that the user added to the cart. And then we want to display all the prices that they have added. So, which is why we implement the for loop next. So in C++, like what I talked about before, if you do a for loop, if you don't want to do the 3 parts in the for loop, you can start with the variable that contains the value for the beginning of your loop, and then the colon indicates that's the container that you're looping in, which is your cart, right? That's the vector. Why don't I do a regular 3 parts for loop? Well, you don't know how many items, how many prices they're going to enter. As you using a vector, it can grow and shrink. So that's why we're not doing a typical 3 parts for loop, is because we don't exactly know how many prices they're going to input, right? So with that for loop, we're gonna display the actual price. So $sign and the P just indicate that's the price. And we want to display the total. And then after that, it will just be return 0. And you're done. And then I'll take attendance in a few minutes if you just hang tight. So if the user enter no in the section where it prompt the user, do you want to add another item? If I press N, right, which is not gonna check true for these two, then it's just gonna tally up everything and display my items in cart. But if I press Y, it's going to come back and it's gonna ask me to enter the price again. That's why we implemented the do while. The do while allow us to re-loop back into the beginning so that way the user can keep, so this program can keep on running as long as they press yes, okay? If they press no, it's gonna proceed to the next part, calculate the total, display the total, and end the program. And so you can test it and be able to check if you can enter all your prices and have a tally. See you later. Bye. Any question? Now, if you want more full-fledged program, you can consider, creating a function to make it modular design, right? Functions for input validation, function for your adding the prices and the total separately. So there are different approaches in this, but just to make a simple program, you can just keep everything in main. Not ideal for modular design, but the whole point is to show you how a vector is implemented, right? There's also other way to write dynamic array, and that could be for another class. But I want to show you, if you need to use a container that contains a sets of data, but you uncertain about the number of elements, use vector. And it has STL, so you have all these great functions that are already pre-made for you. You just need to call the method. So the way that you use it is to add the function to your container name. And then whatever that you want to pass in its parameter. So in this case, we use price. You see that quite a bit in most languages. Python, Java, even JavaScript uses methods too. So, okay. Any question? Okay, I'll stop the video so I can take attendance. If you need to take a look at other programs, if you missed something, let me know. Okay.